Hi guys, this is Vineet and I welcome you to this video. Today's video topic is string and binary data types in SQL Server, and this is part 1 of this video series. So stay tuned. If you have not already subscribed to this channel, please go ahead and subscribe right away. There's a subscribe button below this video. Please click on the subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos, including the videos that I'm making on string and binary data these days. So watch out for part 2 and 3 as well. So if you are subscribed, you will get timely notifications if you have turned them on. So all right, let me take you to notes quickly so that we can start with this topic. All right, so today's topic is string and binary data types in SQL Server. So let's dig into this. So SQL Server supports the following string and binary data types. One of the data types are binary and Varbinary. So here we are talking about two data types. One is string data types and another one is binary data type. If we combine both, there are under binary we have binary and Varbinary data types. So let's talk about them. What are binary and Varbinary? So binary data types of either fixed or variable length. Okay, so if we talk about the binary and Varbinary, what are these? These are data types of either fixed or variable length. And converting data to binary or Varbinary data types is useful if binary data is the easiest way to move around data. So basically, we use these data types if basically they are useful to us in to manipulate data in some easiest way. In those situations, we use the binary and Varbinary data. Basically, then only we convert data into binary or Varbinary, and this is useful only in circumstances when this is the only way to move around data in an easiest way. All right, let's move on to char and varchar, and this comes up under the string data type. So if we talk about the char and varchar, these are basically character data types that are either fixed length or variable length. So fixed size length data types are called chars, and variable size data types are called varchar. Now, if we talk about SQL Server, so if we talk about starting with SQL Server 2019, if we use a UTF-8 collision, if it is enabled and used, if we declare any variable using these data types, char and varchar, these data types stores the full range of Unicode characters. In the cases where we use the UTF-8 collision, these data types store the full range of Unicode characters. And apart from also, in addition to using the full range of Unicode character set or character data, they also use the UTF-8 character encoding. So both these conditions must be true. So and SQL Server 2019 must be there, and we should be using UTF-8 collision along with these char and var data types. In those cases, these data types will store full range of Unicode characters or Unicode character data that uses the UTF-8 character encoding. Next types are nchar and varchar. So these also comes up under the string data type. And if we talk about nchar and varchar, these are Unicode character data types. So by default, if n is present over there, or n is appended to char or n is appended to varchar, it means that these are Unicode character data types that are either fixed size, which is denoted by nchar, or variable size, which is denoted by nvarchar. Now, if we talk about SQL Server version 2012, so starting with this version, when a supplementary character enabled collation is used, so if we are talking about a particular collation here, which is a supplementary character enabled notation or collation, sorry, not notation but collation. So if supplementary character enabled collation is used along with these data types, and we have SQL Server 2012 and beyond, these data types store full range of Unicode character data and use the UTF-16 character encoding. So these data types use the UTF-16 character encoding, and these data types basically contains additional characters when we use the supplementary character enabled notation, and we should be on the SQL Server version 2012 or beyond. Now, next data types also come under the string data types. So these are ntext, text, and image. As you can see, this n text supports the Unicode character set because n is attached to it. Now let's talk about them. So we have n text, text, and image data types. So these basically denote the fixed and variable length data types. So these are fixed and variable length data types for storing the large non-Unicode or Unicode character and binary data. So images for storing the binary data, and text is for storing the Unicode character data, and text can be used for storing the non-Unicode character data. And Unicode data uses the Unicode UCS2 character set if we use the text data type or n-text data type. The character set used is Unicode UCS2 character data set. And if we talk about n-text, text, and image data types, these will be removed in the future versions of SQL Server. We basically recommend you to avoid using these data types in new development work, and also plan to modify any existing applications that currently uses these data types. So these will be removed from the future versions of SQL Server. Now let's go and dig into detail. So first we will talk about the binary and Varbinary data types here. We are going in detail here. So let's talk about them. So binary data types of fixed length or variable length. So binary and Varbinary denotes binary data type of fixed length or variable length. And let's talk about the syntax, all the arguments required here. So we use the binary n notation, and this is a fixed length data type. So fixed length binary data with a length of n bytes. So if we need a fixed length binary data with a length of n types, we denote it like this. And here n denotes the value from 1 through 8000. So maximum value of n can be 8000 and minimum value can be 1. And the storage size is required for this data type is n bytes. Now let's talk about another data type, which is Varbinary data type. And the notation which can be used, or the syntax, we can use it like this. So Varbinary should be used, and within the brackets we can either use n or either we can use max. So this is the or sign. So n can be used or max can be used here. So Varbinary basically denotes the variable length binary data, and n can be a value from 1 through 8000, and max, here we have specified max as well. So instead of n we can specify max as well. So max basically here indicates that the maximum storage size should be used, which is 2 raised to the power 31, whatever comes as a product, then deduct 1 from it. So the maximum storage used will be this in case we use the max data type, or max as an argument to the Varbinary data type. Now the storage size is the actual length of the data entered plus 2 bytes. So in this case, if we define max, whatever, so here we are talking about in case we are using Varbinary data type. So what will be the storage used? So whatever data is there, so whatever data is entered, it requires actual length of the data plus 2 bytes. So the data that is entered can be 0 bytes in length. That can also be 0 bytes in length. So for a 0 byte length data, 2 bytes are required. So plus 2 bytes will add to 0. This will make for a 0 byte length data, we need 2 bytes at least. All right. And if we talk about ANSI SQL synonym for Varbinary is a binary wiring. So in ANSI terms, we call it a binary wiring. And the default length is 1 when n is not specified in the data definition. So if we don't specify the value of n here, it automatically takes the length as 1. So that's the default length. We don't specify anything in the data definition or variable declaration statement. When n is not specified with the cast function, the default length is 30. So if we are using any cast function and we don't specify the length of the n, it automatically takes the default length as 30. Otherwise, for variable declaration, if we don't specify the argument for the Varbinary or binary data types, it automatically takes 1 as the value for n. Now let's talk about the usage. So for binary, use when the sizes of the column data entries are consistent. So we use binary data types in situations where the sizes of the column data entries are consistent, and Varbinary will be used when the column data entries are inconsistent or the length of the columns vary considerably. In those cases, we use the var binary column. And var binary max, we use this basically when the column data entries exceed the 8000 bytes. Okay, let's move on. So let's talk about conversion for the binary and var binary data. So whenever we convert data from string data type to a binary or var binary data type of unequal length, SQL Server pads or truncates the data on the right hand side. And the string types are basically char, varchar, nchar, nvarchar, binary. Binary is also a string type, and var binary is also a string type. Alright, and text and image are, these all are string data types. I think these all are considered under the string data type, although we have mentioned the topic as string and binary data types, but these all data types are considered under the string data type. That's why we have mentioned here the string data types are, these all are string data types. Now when other data types are converted to, so in over the top we are talking about conversion between these types. When we convert any of the among these types, for example, we are converting char to binary or binary to char, and if the data type of the variable are of unequal length, SQL Server basically either pads or truncates the data on the right hand side. Now when data types or other data types are converted into binary or var binary, the data is padded or truncated on the left. So if conversion is within the string data, the padding or truncation happens on the right hand side, and if the conversion is there from other data types to binary or var binary, the data is padded or truncated on the left hand side instead. Now padding is achieved by using the hexadecimal zeros. Now if we talk about converting data to binary and var binary data types, this is useful if binary data is the easiest way to move around the data. So we only use the binary and var binary data types in the situation when this is the only way to, or the easiest way to move around the data. Now at some point you might convert a value type to a binary value of large enough size and then convert it back. The conversion always result in a same value if both the conversions are taking place on the same version of SQL Server. So this is the condition. So if we convert a particular data type into binary value of large enough size, and if we are trying to convert it back into the same data type, the previous data type, the conversion will always yield the same value if the conversions are taking place on the same version of SQL Server. The binary representation of the value might change from version to version of SQL Server. So your SQL Server version should be consistent if you want the same result. Otherwise, if you are using a conversion on one system of SQL Server or one version of SQL Server, and you are performing another conversion on the other version of SQL Server, the result will always not be the same. Now you can convert the integer small int and tiny into binary or var binary. If you convert the binary value back to an integer value, this value will be different from the original integer value if truncation has occurred. So in case of truncations, we might get a different value, right? So this will be in the case if we are converting integer small int and tiny int to a binary or var binary data. And if we try to convert the binary value back to an integer value, this value will be different from the original integer if truncation has occurred. Now let me explain it with the help of an example here. So let me write a select statement for you to state this fact basically. Let's trigger SQL Server quickly. Waiting for it to launch. Should launch soon. In this example, we will use a select statement that will show you that the integer value 1, 2, 3, 4, 5, 6 is what it will be stored as in the binary terms. So let's connect to the default instance of SQL Server. If you have not already installed the test database, I would highly advise you to do so. In my case, I have installed AdventureWorks 2022. You can find the backup file for this on the internet from Microsoft website. You can download that backup file and finally use that backup file to restore the database. Now I'm triggering a new query against the AdventureWorks 2022 database. You can also trigger this query against the system databases as well. But what I would suggest is not to use the system databases. But here we are not manipulating any databases in the select query. So let me use the select cast statement. So here we are trying to do some conversion. We are trying to convert the integer data, which is 1, 2, 3, 4, 5, 6, and we are converting it as binary with the n value of 4. We are storing this data into 4 bytes of storage, binary storage. Now, so we are converting this data into 4 bytes of data. Let's see what output do we get as binary data. Now, you see the output over here, 0x. This is the hexadecimal notation basically, 0x0001E240. Guys, if you don't know about the binary hexadecimal numbers, you need to read about that. Generally, they teach you in the computer science stream. But yeah, if you browse for conversion between the data types, you can check out the online articles on the internet, what is binary data, what is hexadecimal data, and how the conversions are done. So here I've converted a integer data into binary 4 bytes storage or binary 4 data type. Now let me take another conversion. Let me copy the same and try to convert it into binary 2. So in both the cases, we will see that in this case, some truncation will occur. So in this select statement, this basically will show that if a binary target is too small to hold the entire value. So binary 2 is too small to store the entire value here, 1, 2, 3, 4, 5, 6. Binary 2 cannot store this value. So a truncation will happen, and the leading gates are silently truncated so that the same number is stored as 0xe240. Let me show you. Let me run both the statement and you will see the difference. So here the truncation has happened from the left hand side. So these 3 zeros are truncated and even 1 is also truncated. So if we try to store the same number into binary 2 data type, we see that truncation has occurred and the same number is stored as 0xe240. And basically, if we try to convert it back, it will not convert it into same number because truncation has happened in this scenario. All right. So the binary 2 data type is not large enough to store this particular integer value. That's why some truncation has happened over here. All right. So this is a silent truncation, and the same number is stored as this. Let me see if I can try to print what's the integer value of this. So if I try to convert this hexadecimal value, let me copy this as integer. Let me see what value do we get. So we get a different value, 57920, which is not same as this value. So truncation has happened in this statement and a lesser value is stored in the binary 2 data type. And we have shown you, if we convert this value into integer, what will we get as output? We get a lesser value, lesser compared to 1, 2, 3, 4, 5, 6. Now let me show you a batch of statements that will show that this silent truncation can affect arithmetic operations without raising an error. Let me execute this, clear this off, and let me declare a variable over here. Let's declare it as a binary variable 2, and let me define it as binary type with the length of n as 2. Now let me set this binary variable 2 to the value 1, 2, 3, 4, 5, 6. So this data type is not large enough to store this particular value. So some truncation will happen when we try to store this value into this binary value 2, binary variable 2. Now let me set the binary variable 2 to maybe binary variable 2 plus 1. So let me try to do addition. So if we see in this terms, we should get a value 1, 2, 3, 4, 5, 7, right? If we execute this statement, we will get 1, 2, 3, 4, 5, 7. But we will not get that value because here we are storing a large enough value into binary variable 2. And the truncation will happen when we try to store this value into this variable because it has a lower data type, which cannot store the value large enough like this. And if we try to add this value, we will not get 1, 2, 3, 4, 5, 7 as a result. So this is an example I'm showing you where the silent truncation has occurs in the background and we don't get the same result. So we are trying to convert, after adding 1 to it, we are trying to convert back it into integer. So we will not get the same value 1, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 7, but instead what we will get a different value over here. So what we got is 57921. So when we store this value into this variable of binary 2, the value which get stored is 57920 because some truncation happens, and whenever we add 1 to the value 57920, which was actually stored in this variable. One got added to it and we got 57921 as a result. So which I have printed using the cast statement by converted into integer. So the final result is 57921 and not 123457. And if we talk about conversion between any data type and the binary data types, they are not guaranteed to be the same between the versions of SQL Server. So also keep this in mind. This is a very important point. So let me take you back to notes. I think we are done with this topic, which is binary and Varbinary data types. In my next video, what I will do, I will cover the corrector and varchar data types. Notes are still pending. I was writing the notes. So in my next video, I will talk about the char and varchar data types. And you should stay in tune. If you have not already subscribed, please go ahead and do so right away. I'm giving you 5 seconds. There's a subscribe button below this video. Please click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my future and upcoming videos, and including the notification for the part 2 of this video series, string and binary data types. Alright, let me give you 5 seconds, guys. I'm waiting. Please subscribe right away. So guys, I hope you must have subscribed by now, and I hope you must have liked this video as well. Click on the like button if you really like this video. And if you would like to donate or support our channel, if you want to make donation on or offerings to our channel, in case you want to support us, you can do that via 2 ways. So there's a topmate.io link over here. This is the link. You need to type this link as is on the address bar of your browser, like Chrome or Edge. Once you type in this complete link, press enter, it will open my topmate.io page. Once you are on my topmate.io page, you can make donations from there, as per your liking, whatever you want to pay. And if you are using any UPI based apps like Google Pay or Phone Pay, you can make UPI payments as well. I have given my UPI code on the right hand side, which you can scan and make payments to us if you want to support our channel or support our work for future. You can do that. So alright guys, we have come to an end, and I thank you so much for your time on this video today. In case you want to write back to me, you can do so via my by sending an email to me on my email address. It is mentioned over here, vrmavane@gmail.com. Send an email to this email address, and yeah, if I get a chance, I will respond you back. And do not send technical questions to me. Otherwise, if you want to talk in general, or if you want to talk about SQL Server coaching and stuff, and yeah, you can definitely write back to me. Or in case you want to inquire about anything, you can definitely write back to me. Or if you want to share your general experience, day-to-day experiences, you can write back to me. Definitely, but not don't send me the technical questions. I don't get enough time to respond to that, so it would be difficult for me to respond to the technical questions. Alright guys, I thank you once again so much for your time on this video today, and you have a wonderful day ahead. Thank you.